In class, there were some questions about the homework from page 496 to 498, specifically problems 39b, 65, and 79. So I want to go through those problems and take a look. In number 39, you have the application problem that says the number n of pet owners in thousands. That is important to note. It's in thousands, after t years can be modeled by the formula n equals 35 times the log base 4 of the quantity t plus 2. They tell you to let t equals 0 represent the year 2000, and they want you to use the change of base formula to help you answer the questions. So in part A, they ask you how many pet owners were there in the year 2010. If t equals 0 represents the year 2000, then t would equal 10 for the year 2010. And all we need to do in part A is substitute in with 10 to our formula, and n would equal 35 times log base 4 of, when you put in 10 plus 2 really becomes log base 4 of 12. So n's going to equal 35 times log base 4 of 12. And what they want us to do is use the change of base formula to evaluate that. And that's what I'm showing you with a graphing calculator. I'm taking 35 times the log of 12 divided by the log of 4. That's the change of base formula. The log of the argument 12 divided by the log of the base 4. And then, of course, that's being multiplied by 35. The answer we get is 62.736, blah, blah, blah. And we have to understand that is our answer in thousands. So if you multiply that answer by 1,000, that's going to move that decimal point over right here. And if we round it up to the nearest thousand, the interpretation would be that n is about 62,737 pet owners. So how many were there? There were about 62,000, not 72, I think I said, 62,737 pet owners. All right. That's part A. I know that wasn't the question, but that was just simply plugging in. Part B, however, is a little more complicated. It says, how long until there are 80,000 pet owners? That implies that n is 80,000, which in our formula, since n is in thousands, we would want to substitute into our formula for n with 80. So I'm going to have 80, which is really representing 80,000, equals 35 times the quantity log base 4 of the quantity t plus 2. And that is our formula. Make that look a little more like a plus sign. And so how am I going to solve that equation for t? Well, the first thing I'm going to do is divide both sides by 35. That's going to give me 80 over 35, which I will leave in exact form equal to log base 4 of the quantity t plus 2. So at this point, there are all kinds of ways we could solve it. I don't think the change of base formula is the easiest to use here, although it could be done. I think it would probably be more user-friendly to go to exponential form and rewrite this as an exponential equation. And so my equation would become t plus 2 equals the base 4 raised to, which on a calculator you're going to use the caret, and that would be the 80 divided by 35. And if you do that, that should give you the number that you need. And then you will subtract 2 from that answer. So basically, we're going to have t equals 4 raised to the power of 80 divided by 35 minus 2. And I believe that gives us about 22 for t, which means it says how long until there are 80,000 pet owners. It'll be about 22 years, which means the interpretation is the year 2022, our current year. All right, that's 39 part B. Moving down to number 65. How do I solve this equation? I have 2 to the y equals the square root of 3 raised to the y minus 1. I think the easiest thing to do would be to remove the radical by squaring both sides of this equation. We have to understand if we do that, on the left side, we're going to multiply those powers. That would become 2 raised to the 2y. And on the left side, squaring is going to remove the square root sign, so you just have 3 raised to the y minus 1. So at that point, how we're going to solve this equation is to take the log of both sides simultaneously using the power property. So I would have 2y times the log of 2 equals the quantity y minus 1 times the log of 3. On the right side, we're going to have to distribute the log 3 before we can actually solve. And so that means I have 2y times the log of 2 equals y times the log of 3 minus 1 times the log of 3. Since the 1 will look like an L, I'm just going to write minus log 3, which implies the same thing. The y's, unfortunately, occur on both sides of my equation. So the first thing I'm going to need to do is get the variable terms on the same side and everything else on the other side. So I'm going to subtract y log 3 from both sides, which leaves me with the opposite of log 3 on the right side. You could do this many different ways, but I think that is how I would approach it if I were doing it. At that point, I still have 2 y's in my equation, but at least now they're on the same side of the equation. So what I'm going to do is, factor the y out of both of those terms, which means I have y equals 2 log 2 minus log 3 equals the opposite of log 3. And all we're going to simply need to do to finish solving is to divide both sides by 2 log 2 minus log 3. So I'm going to have the opposite of log 3 all divided by 2 log 2. Let me erase that to make it a little more readable, minus 2 log 2 minus, or 2 log 2 minus log 3. Now, entering that into your calculator, you've got to be really careful. Remember, our calculators will put the left parenthesis for the arguments, and you'll need to enclose those. But in addition, since there's more than one thing happening, you're going to need to enclose the entire denominator. The minus in the numerator is probably all right as the coefficient, but when in doubt, it's not going to hurt to put an extra set of parentheses and make sure that doesn't alter your answer without them. The final answer here for y is going to be y is about negative 3.8188. All right, that's 65. Then finally, we come to 79. 79, we are just using log properties to simplify the left side. Right now, there are 3 base 6 logs on the left side. The right side is a base 6 log as well. So if we can condense the 3 logs into one on the left, then log base 6 will drop out and we can set the arguments equal. As the equation is now given, though, we can't just drop the log base 6 and think we're going to take 48 minus 16/5 plus 5, because that's not how our properties of logarithms work. So we're going to combine, and the first operation I see is subtraction here. Subtraction means I need to rewrite those first 2 logarithms as a single log, base 6, but I'm taking the quotient, I'm literally taking 48 divided by the fraction 16/5, and then I still have plus log base 6 of 5 equals log base 6 of 5x. It probably would be a good idea to go off in the margin and figure out what exactly is 48 divided by 16/5. Well, remember, that's the same as 48 times the reciprocal, 5 over 16. And the good news is 16 actually goes into 48 3 times, and 3 times 5 would give us 15. So this whole quantity right here just is really equivalent to 15. You probably wouldn't have guessed that, but that means we have log base 6 of 15 plus log base 6 of 5 equals log base 6 of 5x. So now our operation here is addition, and that means we're going to want to use the product property. So we're going to combine these 2 logs into one, log base 6, by multiplying the 2 arguments together. So we're going to take 15 times 5. And now we have log base 6 of, that would be 75, equals log base 6 of 5x. So now at this point, we do have 2 base 6 logs on each, one on each side, and the arguments are now equal, namely 75 would equal 5x, and when we divide both sides by 5, that gives us x equals 15. All right, I hope that helped you with those 3 examples. And if you have more questions, we'll deal with those in class.